morning, all the guests, all the honored guests here in this session. I, David Singh, welcome you all on behalf of Edisoft to this third session on the talks about artificial intelligence, CBSE code 417 for class 8th, 9th, and 10th. So as we talk about data exploration, in literal terms, what we mean is looking at the data. So looking at the data does not mean that you open a spreadsheet and you look at the data set available there. Looking here is referring to the observation, first of all, observing, preliminary observation of the data. For example, whenever you are put up with a graph or any data set, you are put up to be seen, you are shown the data set. What happens is at first glance, you come up with some very quick interpretations. This happens from our experience of interpreting charts and data. So if you're taking the class, you can start the class by showing them a data set. Do not talk about exploration or anything. You just go there in the classroom, and in the opening step, you show them. If they're sitting in the lab, you can put it on every computer or on the projector, whichever way. You show them a data sheet, a sample data sheet, and you leave it there. Do not talk about it. Do not tell the class what to do about it. You just put it up and you move out of the class for 20-30 seconds. After 20-30 seconds, or maybe you take a round around the area there in the school, and you come back if that school policy allows you during the classroom. That's a part of your teaching. Actually, you can explain to your superiors that you move out after 30 seconds, you move into the classroom, and you will find the students talking to each other. Most of them are least bothered with the sheet which you have put up, but many of them are still there who are interested and curious about what the teacher has done. They might be expecting that, okay, teacher would be explaining it, so why to bother about it? But when then you ask them the question, you throw them the question at that by looking at the sheet, what comes to your mind? So let them speak their mind by looking at the data. Well, so you might have prepared a set of questions, 4 or 5 questions that you can ask them to just reveal what is there out of the data. So that is preliminary data analysis. When we look at the data, then we actually carefully look at the data with a critical eye and an analytical eye. When the observation turns into analysis, then we start looking at facts inside the data. That is what data exploration does, number one. But that is not the purpose of data exploration. The purpose of data exploration is not data analysis. Data analysis is the part of the process of data exploration. You actually explore data by analyzing it, but that is not the purpose. That is not the destination. It is the journey. Whenever you are analyzing the data, you are through the journey, but you have not reached the destination. Destination or the purpose of data exploration is to ensure that at the end of the exercise, you have a data set which is suitable for training of an AI model. That is the purpose. So this is what books are talking about in 1 or 2 lines, that we explore data to make it suitable for AI algorithm. Fine, that's technically correct. But how will you elaborate on that? This is how you will elaborate on that in the classroom. Then this is what data exploration is. What is data exploration? Analyzing the data, understanding the data, what it is about, trying to figure out what story the data is telling, and then looking into the trends, the relationships, the indications in the data set, and then rearranging the data, correcting the data, cleaning the data, removing the unwanted data, that is called noise, and fixing the data values and data set finally to prepare it to be fed to an AI algorithm. Now, what kind of data set should be fed to an AI algorithm? That is the question. Second part of data exploration is how to go about it, what all things are involved in data exploration. And the third part is how to practically do it. So we will look at, first of all, the basic fundamentals, the basic concepts related with data exploration here. So as I was talking about data exploration, the first thing is we look at the data and we categorize the data according to the data type. So when you have a data set visible, what you can do is, first of all, you look at the data types and you categorize the data into two broader categories. Data type is something else. Data type actually describes what kind of data it is, like numerical, non-numerical, dates are there, or is it decimal values, the currency values. That is your data type. But when we categorize the data into two types, broader types, that is the sequential data. Mostly it is numeric data. Sequential data is always numeric, where the figures are actually increasing in certain order. And there is categorical data. Categorical data is not mostly non-numeric, like gender. Gender is one very common example of categorical data. So if we look at this, if you see this data set here, this is one sample data set shown to you, wherein it is actually a data set about certain students in a school, in a remote school in a village. So details of those students are there. Some of the obvious details I have not filled in, like names are obvious. Some names would be there. Family, occupation, location, I have not filled in. That can be filled out in real life scenario by survey, that can be done. So what we are trying to see, what will be the dropout status eventually in that school. So we are looking at so many data values like gender, age, height, weight, absenteeism, how regular is the student. If absenteeism is okay, but how regularly the student is coming to the school, and many other parameters are there. And by looking at this data set, we will try to figure how many students will actually might get dropout. The prime concern of government today is that school dropouts are so many in especially those remote schools. So to ensure that children should come to the school, that is one primary focus of new education policy also, that to decrease the dropout significantly. So this is one situation where we try to figure which variables are actually going to affect or help us in predicting whether the dropouts would be higher or not. So in this small data set, it is very easy to figure out, like obviously absenteeism and regularity will be the deciding variables. What is the age of the student is not determining his or her dropout. Up to some extent maybe, but that's not a very deciding parameter. Then gender, up to some extent, if you look at Indian culture, where boys are encouraged more to go to the school as compared to girls. Things are changing now drastically, yes, but still. So gender, up to some extent, in that purview, gender might be affecting the dropout. Then family, occupation, family income. Family income will tell us about the poverty level, or how well off the family is, and whether they can afford the child to send, because in poor groups of society, what happens is children also go out to earn, so they do not go to the school. So here family income up to some extent can decide, or if we could have included a parameter here, number of earning members in the family. This parameter is not here. So did you see? So this is what I'm doing is, this is the preliminary analysis of the data. What I'm doing without applying any technique, out of my wisdom, out of my experience, I'm doing the preliminary analysis of the data. So preliminary analysis actually helps me to get a hang around the data, okay, what it is about, what all figures are there, and how does it make sense. So first thing what we do with our data set is, whatever parameters are there, suppose 20 fields are there, out of those, with our preliminary analysis, we just pick out which could be the deciding parameters, which seem to be very important. We take out those and we analyze them individually. So in the first phase, what happens is, in the data set, the parameters are analyzed individually, irrespective of what is the relation of theirs with other variables. So if I'm talking about family income, if I'm talking about absenteeism, we pick these fields separately and we apply certain techniques separately on them. The reason is, the first thing which actually disbalances your data is the outliers. Outliers is one big problem in real life, because outliers, now first of all, what actually outlier is? Outlier is that value which falls very far on the graph from all the other values. For example, in absenteeism, suppose somebody's absenteeism is 90% and rest of the class is maintained well within 60%. So that 90% is far off from 60%. So that's an outlier. And what is the impact of outlier? The impact of outlier is that it makes the data imbalanced and biased. So if you're not taking care of outliers, the AI algorithm will be trained in an improper way. It will develop a bias about it. It has certain outlying data, and that will all shake your averages. It will shake all the balance of your data. So first of all, you have to identify the outlier. And once the outliers are identified, what you do is you have to take care of those outliers. How? If they are not important, that depends on the scenario, that depends on the decision of the data analyst. If they are not very important with the context, they can be removed. Or if outliers are too many, if there are very few outliers, they can be removed. But if there are outliers which are too many of them are there, then we can group the data. We can try to group the data and accommodate the outlier into one of the groups, if possible. So this way, outliers up to some extent can be involved into the actual data. Or we take the averages of the values and then we try to segregate the outliers. Or if outliers are too much in number, suppose out of 100 values, there are 20 outliers. So you can put them in a separate category. You can treat them separately. And you take a single average and put it with the other values. So this way, some sort of handling of outliers can be done. But mostly outliers are actually gotten rid of. They are not kept in the data set. So how do we detect outliers? There are many ways we will look at it. Then we ensure, after identifying outliers, we also ensure that the data spread is uniform. It is homogeneous. If you have attended my previous session, I talked about variance. What variance actually is? We take the average of all the values. Suppose you have a family income. You take the average of the family income, and then with this average, you take the difference of each of the value. If that is very high, then your data spread is not proper. Your data is very much scattered, and you have to look at outliers, and you have to apply certain techniques to take care of that. So normal data distribution has to be there. So these techniques actually also tell you whether the data collected is correct or not. And then you can investigate whether the data acquisition was done properly or not. So in this preliminary analysis, you detect outliers, you see variance is very high. Higher variance means the distance between the average of all the values and the individual value is very high. So that should not be there. Smaller is the variance, values are closer to the average, closer to the mean. So calculating mean is one very important thing. Calculating mean, median, mode, this we had discussed last time also. What is the purpose of these all things? The purpose of calculating mean, median, mode, variance, standard deviation, minimum value, maximum value, you take all these figures just to analyze whether the data spread is proper or not. And that way, the collected data validity can be ascertained. So this is one thing. Now, this is all good for numerical values or sequential values. What about categorical data? Categorical data like department or gender. So this kind of categorical data, location, what we can do, we can see their distribution by the help of pie chart. So those values can be counted. For example, male and female, boys and girls in a school. We can count how many boys are there, how many girls are there in the data set. And then we can prepare a pie chart simply to look at the distribution, how many percentage of girls and boys are there. Or the same thing can be done with bar chart. or frequency tables can also be made. With a small moderate data set, you can go for frequency tables also, like you see one table here. This table is exactly telling you the difference of 200 between the male and female going to school or not going to school. See, so male, female is one side. They are going to school or not going to school. How many of them? And then we take the totals. So this gives you a pretty good understanding of the data, what is there. And you can take conclusions out of it. So this is what data exploration initially about. First of all, you get the hang of the data, you see what is the data about, and you identify the variables, the values, you categorize them, whether it is sequential or whether it is categorical. This you have to decide. Then moving further, then we look at the missing values. In real life, what happens is when you are actually accumulating the data through certain techniques from databases or from data files, there will surely be missing values. So missing values actually again create bias for your AI model. So missing values have to be the reason of these missing values, data acquisition, how the data acquisition is being done, how the data collection is done, whether there was an error in data entry, the data entry operators were not doing their tasks well, their job well. And how do we treat these missing values? If missing values are not putting that much impact on the actual data, we can remove them. That is one thing. Then we can recalculate certain missing values. Some missing values can be calculated out of the existing data. For example, sale value. Sale value is missing. So if the quantity and price is available, you can calculate it. Or you can predict the values also. For example, if it is male, female data is missing, but salutation is there, Mr., Mrs., Miss. If that is there, then you can easily guess whether you have to put a female or male value there. So this way, out of your wisdom, out of your intuition, with your by relating the data, some of the missing values can be predicted also. So this way, by prediction and calculation, we can fill in the missing values, or if they are not putting any impact, then we can delete them also. So idea is that in the actual, in the final data set, there should not be any missing values. Then correlation and causality. This we had seen in my last session also in regression, where we see that the values are there, how they are correlated. So we can prepare a simple chart in Excel, or we can use a tool called Solver. There is another tool in Excel called this data analysis tool. Using all these tools, you can see whether the data is properly spread and correlated or not. Correlation has to be between minus 0.1 to minus 1 to positive 1. So this we had seen in our last session, how data is correlated by making simple chart or applying solver algorithm. And then we see how one set of data is impacting the other set of data. That is another aspect. One aspect is that suppose you take out the absenteeism figures, you see how these figures are distributed. That is one thing. Another thing is absenteeism is there, suppose, and performance is there, the marks. Now you try to correlate them. So how they are correlated? So you have to see the correlation between the two or more variables. So correlation has to be there, and the data spread should be properly. This we look at, we consider these things. And what is the direction of the correlation? Whether one value is increasing, the other impacted value is decreasing, or it is increasing or decreasing along with how it is. What is the direction of the correlation, negative or positive? And yes, whether there is correlation or not, that is also important. And also you have to look at the data, you have to analyze if you are going to add some more parameters into your data set. Suppose I said that we should have included another field into the data set. Now, after adding another field into the data set, how the other data values are impacted now, how they are changing their behavior, that has also to be analyzed. So this all analysis has to be done to see how change in one variable is causing the change in another variable. So this analysis actually helps us to find out how the values are correlated, how absenteeism is correlated with performance, how family income is correlated with poverty index. So this way we can correlate the values and find out which values are important to be kept in data set. And if we are not able to find the correlation and causality among the data values, those data values can be removed. For example, height and weight of the student is not going to affect the absentees. So height and weight can be eliminated. They are not necessary there. Even name is not necessary, but name is just to kept for the identification. So that is there. So this way, correlation and causality has to be understood. For that, you can apply linear regression or multiple linear regression techniques, which we had seen last time. In my session, you can watch that video in Knowledgeverse YouTube channel. Then we look at the most important part of data exploration, that is feature engineering. Now, feature engineering is what? When I tell you what kind of story data is telling, that is one aspect. Okay, you are able to interpret the data as it is. Feature engineering is actually playing detective. You might have seen detective movies where something strikes to the lead detective by looking at the available evidences. And something strikes him, and that leads to the climax of the movie. So feature engineering is that interesting. You look at the data and you figure the hidden, what is not seen in the data, the hidden features coming out of the data, which at first glance are not visible. For example, you are analyzing the absentees of students in your school, maybe your classroom. As a class teacher, you're looking at the absentees in your school, and you pick up all the previous data, previous 6 months dates you have taken out from register, and each and every student you are analyzing when that person was absent. So you have the dates on what dates, which students were absent. You figure out and you try to group them. Okay, on 10th of January, these 5 students were absent. On 15th of January, the same 5 students were absent. This is one thing. You are able to do that. Now, hidden feature is, out of those dates you analyzed, you looked into the day of the week, Saturday. Most of the students are absent on the day from which the next day is a holiday. So most of the students are absent on a Saturday. If second Saturday is a holiday in the school for students, most of them are absent on Friday or Monday. So you are analyzing that most of the students are going away, putting up fake applications. I am down with fever, I have this and that, and actually they are absent just before the holiday. 2 days holidays there, 1 day they take away with the leave, with the absenteeism. So they are actually enjoying a longer holiday. And this analysis has come up, and then you come up with a strategy. Okay, somehow I have to manage this. I have to be very careful when the students are going on leave, especially when there is a Sunday next day or a holiday. So this is something hidden which you have taken out from the data. Data was not holding that. When you split the date into name of the days, days of the week, then you were able to see that. The same thing applies to a business and e-commerce website, where they can analyze that on a particular day, the visit of the customers, not on a particular date, but particular day of the week, the visits are higher or lower on their website. So this is something called feature engineering, finding out the hidden data from the data set, hidden facts from the data set. And that actually helps you interpret the data set in a better way for the AI algorithm. And once you have found that hidden information, how do you do that? You transform certain values which are suppose family income is the value in thousands. Okay, absenteeism is in hundreds or tens. Now, a vast difference between the two. So you can divide the family income by 100 and you bring it down to which matches with the absenteeism. So you can put up a better graph and you can look at the data in a better way. Because putting the values on graph, one value X is in tens and Y is in thousands, then the graph you will not be able to understand the graph properly, and you'll not be able to relate the things together. So bringing down the values up to a common standard platform. So this is called feature engineering. Or you generate new values out of existing data. Like I told you, days of the week from the dates. That is one example. So as you see here, this is one simple Python coding where we are using pandas package. This pandas package is actually helping me to read the Excel file. If your data set is in Excel file, you can use pandas read Excel method here, and it will give you the data frame. DF is the data frame which holds all the data in the sheet, and you can simply print that data frame. See here, the output of entire, all the data is shown here in the data frame, simply dumped here like raw data. So this you already know, I suppose. Now, if you want to display, if you want to read CSV file, then you can use read CSV method of pandas package. And if you want to display selective columns, then you pass a list of Python list of those column names. So I am passing the Python list of column names, age and gender. See, this is in square brackets, hence the list, and it is passed as parameter to as an index to data frame. You see, there is a double set of square brackets. So this square bracket is of data frame. Second set of square brackets is for the list of the columns. So list of the columns is actually put as the index of the data frame, and then this thing entirely is passed into print function. So it will display only the age and gender. See here, only the age and gender, two columns are displayed here. So this is just to show you how the data has to be accessed using pandas package. Then we can go for simple analysis. For example, if we look at this, first of all, let us look at the output. Just look at the output first. What we have done, we are analyzing the income, family income. So average family income, the mean is taken. The mean of the income is 12,000 approximately, and median is also 12,000. Most of the people, income mode is 8,500. Mode is what? Mode is the number of similar values which are closer to each other. So most of the people are in the income bracket of 8,500. Then see the variance and standard deviation. Standard deviation is nothing but the square root of variance. If you multiply standard deviation with itself, you will get the variance, and vice versa. In variance, you take the square root. So standard deviation is around 3,000, 2,839. So what is standard deviation or variance here? Standard deviation is saying that if we take the mean, if we take the average of these income figures, income figure average is around 12,000. So the difference between each value and 12,000 is approximately somewhere around 3,000. So roughly all the values are 3,000 rupees away from the average income. So this is what we are analyzing here. So income disparity is too much. So what we analyze here is standard deviation is too much. It is almost the 10%, or you can say 25% of the average income. See, this is approximately 3,000. This is 12,000. So 3,000 is 25% of 12,000. So 25% difference is too much of a standard deviation. That means the income of the families is in much difference. You see here, if we take, I have taken the unique values also. In unique values, the least income is 8,000 and the maximum income is just double of it. See the figures, how they are increasing. So there is a big difference among the values. So this data is not dispersed very well, but that does not mean that we will discard this data. These are the real values. And if we see the disparity, we just check whether the data is collected properly or not. So if we see that this data was collected properly, then we cannot do anything about it. We have to accept it as it is. So this is just one example how you take average, median, mode, and standard deviation, all these things out of entire data. Now we see how do we do it. We have seen how does it look like. Let us come to the code here. First of all, for all the statistics and numerical calculations, what we have done is we have imported NumPy. That is a numerical analysis of the data. It is a useful package for that. Statistics package is also useful somewhere. So NumPy and statistics will help us, will give us the methods to apply statistics on the data set. Pandas is used to actually load the values in the memory and access them. So with the help of Pandas, we have read the CSV as usual. And what we have done is from the data frame, we have taken out family income. Family income parameter we have taken out here. And all the family incomes from the data set will be loaded into a variable called income list. So income list is actually not a variable. It is a set of figures which contains all the family income. Once income list is loaded with the data, we are applying mean, median, mode, variance, std dev, and unique methods. These methods are available in the respective module here, respective package. Mean, median are available in NumPy. Mode is available in statistics. Variance and stdev are available in statistics also. STD is also available in NumPy, but I have used statistics here. And in NumPy, there is another method called unique. It will give me all the unique values. It will eliminate the duplicate values just for the clarity of the data. Maybe I want to look at the unique values. So once this all is taken out, it is simply displayed back. Of unique values, what I have done, I have applied len method of Python. It's a simple len method Python library, the de facto library. And it is telling me how many unique values are there. 18 unique values are there. Out of 20, these are the 18 unique values. So this way, preliminary analysis I'm doing here, basic statistics I'm performing here. So what do I do? If I, in this entire code, what I have to do, if I have to analyze another parameter, I just need to change the name of the parameter here. Suppose I want to take the age. I just change age and I rerun it. Now what I get is age here, see? So average age is 10 years or say 11 years. So average age is 11 years. Median is also 11. Most of the students are of around 12 age. Don't read income here. It has to be age actually. I have to make a lot of changes here, so I'm not doing that. Let's analyze the figures. So this all is very close. So that means age is evenly distributed. That is good. In this school, students of properly distributed age are coming. Even deviation is very less. See, 3 only. And unique out of 20, there are unique 8 values. So this way I can analyze the data, whether it is balanced or not. Income data was not balanced. So I can investigate how it has been collected, whether it is correct or not. Age is okay. So this way I can make changes in the name of the parameter here and I can analyze the basic things. Moving further. That is the same thing, the same code. Now, let's have a look at this code. Most of it is, as usual, understood. Most of the things are common here. See what we have got here. Look at the figures. Do not look at the graph. This is the data about age again. So I have taken maximum age here, minimum. In earlier analysis, maximum and minimum values were not there. So I can have a look, okay, highest values, lowest values are what? So it will give me the extent of the data spread. Minimum value is 7, starting from 7, ending to 17. Between these two values, all the values are spread out. Average values we had already seen, around 11 years and 12 years, very well spread. Deviation is very low. Then I have taken another figure, percentile. Now percentile actually gives me a very interesting kind of value. how many percent of students here are of age 12 or less? Less is the keyword here. So if I'm saying percentile 12 means I'm looking at what percentage of students is less than 12 years, 12 or less. If we look at percentile function here, look at this percentile function here. Percentile method is in NumPy. I have mentioned here 75. That means 75% of the students are of age 12 or less. If I make it suppose 80 or 90 and I run this, the percentile is 15.2 or let's say 15. So this says that most of the students are of age 15 or less. Let me make it 50. So this is what I'm doing. I'm actually doing some sort of analysis. I want to find out how many students are of a particular age or below it. 50% of the students I want to figure. So here I have made 50 and let's see what is the percentile. 11. That means half of the students are of age 11 and below. And 11 is the figure around mean also, median also, and mode also. So this way I can see that my data is homogeneously spread. Age is proper. The collection of age data was done properly. So this is how I can use percentile. I'm not going into the graph part right now. We will look at it later. Then we can also perform simple query on the data set. So you have loaded all the data in the data frame DF. DF data frame has a very interesting function called query function. This function can be used to perform, to take out selective data from the data set. No need of any sophisticated database. Quick query can be done on the data set loaded in the memory. Query function, actually query method takes the condition. For example, in single quotes I have given age is equal to 9, double equal to. Age is equal to 9 means I want to show all the details, all the age, 9, exactly 9. If I run this, so I get all the data, entire data set where age is of 9 years. So this way I can perform query. Another example of query method is here. You can use AND operator to combine, and OR operator can be combined to put in multiple values here. Now see here I'm saying that age should be 10 and performance should be less than 50. So which are the students who are 10 years old and their performance is poor? It is less than 50. I want to figure out and this is what I get. There is only one record of that. Now pay attention here in the code. Query function is actually taking a parameter. Earlier it was taking only the parameter. I passed only the parameter. There is the second parameter in place. I did not use it earlier. By default, in place is false. But what does that mean? In place, if you make it true, what it will do is it will not only give the output of this result, it will modify the data frame also. So when I'm saying in place is equal to true, that means data frame now has got only this value, what is shown in the result. Rest of all the values are removed from the data frame. And that's why when you are using in place is equal to true, your query is not returning result here. Your query is not returning result. That is why none is the output. If you are using in place is equal to true, number one, query will modify the data frame physically. And it does not need to return the result now. You can simply display the data frame and see the result. So result data frame is replaced by the result. If you say in place is equal to true, but if you say in place is equal to false or do not use it, what query does is it keeps the data frame intact. Data frame is not modified, but the result of the query is returned. And that result is displayed here. See the difference. So if you want to modify the data frame itself, then you can use in place is equal to true. In that case, you do not need to do this. I'm removing this. This is not required. I kept it just to show you that when I was printing result, it was showing me none because there was no result returned. So I do not need this. With in place is equal to true, data frame itself is modified. I simply display the data frame. So this is how simple query can be performed on the data set. Now we look at various visualizations. We have seen the basic statistics, how we look at the data, how we understand the data. Now, how do we interpret the data visually? So for that, we can create different kind of figures. For example, if I create a pie chart, suppose, pie chart on genders. Let us see the output first. So pie chart is useful for displaying the categorical values, the values which are not numeric. You can see the distribution of such values. So maybe income groups are there, high, low, medium, gender is there. And how do we do that? To create the graphs, we have the library matplotlib. Matplotlib has a component, has a module called pieplot. Pieplot actually helps us in creating various kinds of charts and plots. So I have taken MTP as the reference of matplotlib pieplot module. I have opened the CSV file. I have brought the data frame to load a list of gender. All the genders M and F values are loaded in the list here. And then I create a pie chart. See, this is the pie chart. In pie chart, I have put certain values. See what I have done. If you remember, in NumPy, there was a method called unique. Unique method is very useful. It also returns, if you say return counts parameter is equal to true, it returns two things. It returns unique values as well as count of those values. And unique values and count of those values, these two are required to plot the pie chart. Unique values will give you FM and count will give you the number of F and number of M. These two are required for the pie chart. So I have used the method unique first of all, taken out the counts and unique evals, unique values. These two are passed into the pie chart like this. First of all, I put the count, and in place of labels, I have put the unique evals. Unique evals is the list of F and M. Labels parameter is used. Labels parameter is of pie method. So pie method, first of all, will take all the values. You can pass the labels. If you do not do this without the label, the chart will be called. Start angle is equal to 90 degree means start drawing my pie chart from the top. You see this 90 degree from here. The pie chart will be started drawn from the top. So this angle you can decide. Shadow is just the decoration. Shadow is equal to true will give you a little 3D look of the chart. So this is how it works. These two parameters are important. How many values? The counts and the unique values. So pie chart is created. MTP reference has a legend method. Legend method takes title parameter. You can give a title to the legend also. So legend is added here. You see this box. This legend is added explaining what is what in the chart. And finally, I display the chart. So this is how I display a pie chart here. Similarly, I go for a scatter chart. You see, this is a scatter chart between absenteeism and performance. Absenteeism and performance, these two are taken out as list 1 and list 2. And then a scatter chart is made by using a scatter method of matplotlib pieplot reference MTP. The first parameter and the second parameter pass to it. Rest is decoration, color and size. This is just the decoration. The first two parameters are important. X and Y are passed to it, list 1, list 2. Grid is just to show these grid lines. And then finally the plot is shown. And just by looking at it, you can see that there is correlation. However, loose correlation is there, but higher the absenteeism, lower is the performance. Did you notice? 80, absenteeism is 80. See how many of them have performed around 40 and below 40. And as the absenteeism is 20, very few people, very few students who were regular and present, they have performed well, above 80. And those who are moderate between 40 and 60, their performance is also moderate. So this is a very good spread of data, very good relation of the data, and you can figure out that absenteeism is actually causing the downfall of the performance. The performance is going down because of absenteeism. So that's a very clear example of correlation and causality. Causality and correlation are shown here by the help of a scatter chart. You can have a better look if you draw an intercept line also in this code. I have drawn an intercept also. So this you can create in Excel also or any spreadsheet. So this is also giving you a clear picture that it is a negative correlation. As the absenteeism goes up, performance comes down and vice versa. And how it is done? You created the scatter chart as usual by passing the first two values, absenteeism and performance. And then from NumPy, you call a method polyfit. Polyfit will take list 1 and list 2, and it will give you two values. You remember, if you have seen my last session, I told you that in regression, there are two aspects, slope of the line and intercept of the line. So this polyfit function will take the absenteeism and performance values. It will perform some calculation and it will give you the slope and intercept. This slope and intercept is used in plot method. Plot method is actually drawing this line. Plot method is drawing this line. And what are we plotting? We are plotting across the performance. So I have passed list 1 here. And what is the method? You remember from the previous session of mine, regression ka, there was a method that is, there is a formula of regression that is slope multiplied by the parameter x added with intercept. Slope into x plus intercept. So this has been passed here. And the moment it is done, it will calculate through which points the line should be drawn. And finally, I show it. This way, regression can be done by using polyfit and plot methods in Python itself. And as I told you, just by looking at this regression, we can figure how correlation is happening and how causality is happening. So this way, charts can be drawn. Let us quickly have a look at this box plot. Box plot chart is drawn to find out the outliers. See, these values are most of the values are just spread in within 30 range of 35 and 60. But there are certain values of performance. Some performance is 80 and above. Some performance are just 20 marks, 20%. So these are outliers. These are outlier values which are very far off. Similarly here, this is your absenteeism. I am seeing the spread of absenteeism. Absenteeism is very well spread except for there is very high absenteeism at one end and 5 absenteeism is at one end. So these values I need to eliminate from the data set for the proper training of the AI algorithm. So this way, box whisker plot can be created. For that, you just need to call box plot here. So I called box plot and I have passed the performance here. List 1 is performance. Vertical is equal to false means it will be drawn horizontal. So box plot is fairly simple. You just pass the values and you simply show it and it will be displayed. Box plot for list 2 is created here and shown. So these are two separate box plots. This way we have seen that how data is analyzed with basic statistical methods in Python and how data is visualized using by creating charts and plots on the data sets. How we can query the data from the data set, whichever we require. We need not to handle entire data set. So this way, by relating all these things, we can interpret the data in a better fashion. So well, friends, this is time to say goodbye. Thank you once again, all of you. And I'll see you hopefully in the next session. Thank you, one and all.